Welcome back, guys, to Calc 2 Week 7. This has nothing related to do with any calc homework if you looked this up and just happen to find it. Starting with number 1 for this week, it asks you about a manufacturer of headlights who wants to produce bulbs that last about 700 hours, blah, blah, blah. Let FT be the fraction of the company's bulbs that burn out in T hours. And you have to keep that between 0 and 1 because it's a percentage. So, anyway, starting here, if they expect that by 700 hours, all of their balls will have burnt out, or at least a high number, then this should be how the amount of them, the trend of them would go. Start lower, and then the closer it gets to 700, the higher the percentage. I converted the 1 into 100% just because it made more sense for graphing. That says percent burnt, that says hours. Question 2 asks, what is the meaning of the derivative RT equals f prime of t? I just kept the f prime of t for both of my answers to make it easier. But f prime of t shows the change in the percent that blow out over time. So it basically just shows how many of these, or the percentage of this would show how fast these are going bad, kind of. And if you take the integral from 0 to infinity, it would equal 1, because by an infinite amount of time, 100% of the lights will have burnt out. And 100% in this situation is 1. Number 2 asks you to estimate the total amount of water leaked over time given this table. I guess I can just show you. I didn't feel like writing out every problem this week. But to start, you find your delta x, which is, you take b, which is 6, minus a, which is 0, because it's from 0 seconds to 6 seconds, and then divide by n, which is also 6, because you have 6 data points, which equals 1. That's easy. You put delta x over 2, you get 1/2 times 4 plus 2 times 3 plus 2 times 2.5. And basically, I'm just going through every one of these data sets and multiplying them all by 2 and adding them together, except for the one at 0 and the one at 6. So that's what I did. I get it out here. Them all added together is 24.5. There might be slight addition error because there's just so many data points, but the idea should be right. Then you divide by 2, and then you get 12.25. For number 3, it's a little more complicated. You have to use Simpson's rule instead of the trapezoidal rule. And your delta x is, well, use this, right? So your B is going to be 12 because that's the 12th month. Your A is going to be 1, and there are 12 data points. So 12 minus 1 over 12 for n equals 11/12. Then you bring that over here, you put your delta x over 3. 11/12 over 3 is 11/36. I did it wrong the first time, that's why there's a few scribbles. Forget how division works. But then you multiply that by 1 times your first data point, plus 4 times your second, 2 times your third, 4 times your fourth, and so on, doing the 4-2 pattern all the way to the end until you do 1 times your last one again. This is all the estimated numbers I got from this graph, just looking at those dots and trying to see to the left. I did calculate this in Celsius because the numbers seemed easier to read. And at the very end, I got 365 times 11/36. And then that equals 111.52 degrees Celsius over the course of the entire year.